Okay, so I have 38 minutes, so I'm gambling that I can finish this to have a solved problem until midnight. So let's see. K-divisible components. So we have a 3 edges and we got each each node has value and then we have K. Resulting all have values that are divisible by K. Oh, okay. Maximum number of components in any valid split. Okay, that's interesting problem. Sum of values is divisible by K. Okay, it can be a lot and times values, so definitely, so sum of values is divisible by K, so we can have at least one component. Okay, so the question is that well, how do we solve it for root? Maximum number of components. So I think this is gonna be a 3dp, and my idea is that, I mean, of course I could first brute force I could think of is trying to remove whole subsets of edges, but that's obviously 2 to the n, which is gonna be slow. So now let's say we root the tree somewhere. So let's say we root it here. And now max components, we can have a component with value 0. So we have a few options if we are at root. Root is gonna be connected to some of these guys. Some of them. Maybe not all, but we want to maximize it. So what's K? 10 to 9, so we are not doing DP on K. Let's say, what's max, if I remove this, then if this subtree has some divisible by K, then it can be separate, but the rest also has to be divisible by K for that to work. So and now if let's say this would be by K, this whole thing is divisible, blah 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 blah. If 3 divides 7 plus 5, yeah, that doesn't say anything about dividing either of them. Oh, why did I pick the hardest problem? But I'm gonna give it 5 more minutes before reading this hint, or 10 minutes. Sounds like a standard problem if you ask me, but I'm not sure right now, so mean, if you remove this, then you want to make, even if this, let's say I remove this edge, even if this would have to be split into multiple components, so K is 3 here, so if this would be 3 and this would be 2, right? If it should be split into multiple components, if this would be divisible by K and this is not a valid this and this is not a component, so who cares, but you know what I'm saying. The rest has to be divisible by K. So we can remove all subtrees that are divisible by K themselves, such that the rest is divisible by K. So I can calculate the answer for root. Now the thing is, what do I need for that? Sum of subtrees, I can do that with a DFS. Okay, and now what if I want to move to a vertex? Well, I want to be able to do the same thing. I can do the same thing for these children, but what about these children? That's a different story. So I want to solve if sum of this, which is sum of entire thing minus sum of this subtree, is divisible by K. Well, I can know if this is splittable into some components, at least one, by the sum. But what's the best amount of components it can be split to? And how can it be recalculated from so I want to calculate the best split without this. In this subtree. Well, what is the answer for that? I have no clue. And if I would calculate the split for this, what would be the answer for that? So for each vertex, I want to try to solve the problem without that subtree. And what is the answer for that subtree? I already did the 3-hour competition today, and before that 4 hours of probability and statistics, so I'm fried, but whatever. Oh, wait. If at all, yeah, good point. If in the maximum option for this vertex this is separate, then I would have computed easily the answer for the rest, because just answer for this minus answer for that. So we are okay. I might have gotten it, but I will be cutting it very close if I don't. Let's say I got 20 minutes for this. Okay, so let's do vector VPN, I guess. And then I want to count sub, but it should be long, so vector long of sub is the sum of, or let's call it sum, who cares. I need to build a graph, so okay, so we build a tree. Auto def cannot be auto if I want the recursion, but I could pass self and then it should work, I think. So auto DFS, I guess that works. This, and then it's self. I'm not sure that works. There was some trick which could do this, but whatever, I like to do this. So int for parent, and then DFS in this, let's call it DFS0. We start from vertex 0 and parent is -1. What we are doing is just calculating sizes of sum of values of sub3. So sum v values v gv if u p bfs uv sum v sum u. That's it, that's the whole thing, that's the whole shtick. Let's see if this runs. Maybe I can do it in one DFS. I guess I can. Or can I? Maybe not. I don't know. Let's do another DFS. Okay, so now we skip this. It's gonna be called DFS1 because why not? So we solve for children, and now after we solve for children we want to do this. So let's call it long 1ll times this, and let's call it sub3. Who cares? So it's sum of w, and we want to go through the children, and we can remove all children that have if sum of u percentage k0 and total sum of 0 and sum of total sum of u percentage k0. Okay. Let's say you have multiple. Let's do it like this. So then do sub. So what I'm doing is just checking if I can remove this component. Means that this has to be divisible by k and this. And if that is the true, that is true, then sub minus equals sum u. And then well, we'll have one component, so dpv plus equals dpu, I guess, maybe. It should be 1. And I guess that's it. So it's trying to remove all such components, and if parent is not -1, then we have a special case. Ans max, ans dpv. Okay. Yeah, it's not minus. What? So if it has a parent, then if sum v percentage k0 and total minus sum v percentage k is 0, then dpv is equal to but I will not compute parent before I compute this, so that kind of sucks. Maybe I could do it in the second pass, because if I do all my children, I mean, okay, that kind of sucks, because I wanted to use parent's answer, but I don't have the parent's answer because it's a DFS. Haha. Okay, maybe if in one pass I compute this, and then in another pass, I guess, but oh my god, bro, are you kidding me? DFS1 void int 3 DFS functions. Oh my god, bro. Hell no. So DFS to UV, fair enough. So you do it for all children. And now if sum of v percentage k is 0 and total minus sum v percentage k is 0, then dp v is max dpv, and because I'm gonna compute this from children, I guess that could work. Nothing matter? Maybe. Okay, fair enough. Left v minus equals this, and if the rest that is left minus sum in there is divisible by k, then we want to dp of parent also has to be, then we add dp parent minus, so dp is dpv plus dpp minus that's weird. That doesn't work, I think. So the answer for this computed for this, and now answer for, if we want to cut this, is answer for that guy minus answer for this guy, if we can even split it like that. So dp parent minus dpv. I have no clue what I'm doing. I didn't call DFS to redefinition of left. There is no way this will work. There is no way. Wrong answer. I don't want to draw this, bro. SMH my head. Let's see. I mean, I am writing a couple of cases, so now you won't really see what I'm doing, but I still have 5 minutes, 13 minutes, but whatever. I can figure this out. So 0 goes to 5, 5 goes to 1, 1 goes to 6, 1 goes to 7, 5 goes to 8, 0 goes to 3, 2 goes to 4. So from 5 to 2 and from there to 4, and then the values are 3, 0, 10, 0, 6, 1, 1, 3, 0. Okay, and case 8. So I'm in here, and well, let's say I compute the, let's just immediately write out both DPs. This is a trick from Gennady. I saw in some of his code. 2, 1, 1, 1, 1, 2, 3. What is, how is 4? Oh my days, what? Well, this can be a component for sure, one of them. How can this be 4, bro? How? I mean, this could be its own component, and this could be its own component, and then this is okay. Plus, this is not gonna work. That is weird, bro. The zeros make problem. Ugh. That sucks. Well, I treat this whole thing as one component. So I cannot cut this guy off. So I pretend that what max components I can do this as. Or can I even do it as a component? Maybe it could be a simpler DP of I take the parent and I don't take the parent. Well, if you take from the parent, you remove all possible components. And maybe his parent component. Oh my days, I picked the wrong problem. Okay, let's see some hint. What? What? Wow, why didn't I think of this? Holy. What? Okay, that's crazy. That's crazy, dude. Oh shit. Oh shit. Holy. What? It's that simple? Are you kidding me? And I'm doing this disgusting dynamic programming. Okay. Then I'm truly cooked. Let's see, well, one DFS I will let here exist, and this will return some int. I mean, their logic makes sense. If some leaf is divisible by k, then it should be whatever. Maybe I can even return this. What it returns? Number of components. So does it really have to be? If subtree size is divisible by k, then we just cut it off. So 1 plus the number of cuts, so we return the number of cuts. We go through my neighbors, and if q is not p, then we DFS. It is even possible to do with DFS. And now, if sub of u percentage k is 0, then well, res plus equal or res plus plus. One component. Well, then we can have one more component. And sub u is gonna be 0. And then sub v plus equals sub u. And then we just make this. And then sub v is equal values v. And that's it. Lambda expression. Maybe I don't even. Let's return answer. Okay. Well, that was that simple. Okay, whatever. I guess. Question is, this might not even be necessary. I think this is not necessary. Yep, you don't even need to reset it. You can just do this. That is that simple DFS. Holy, okay. Nah, I was just doing too much with the DP. That was useless. I am stupid. I forgot to speak, but I mean it was extremely simple once you look at the hint. I mean it's a hard problem because of the idea. I was doing some useless DP, because if that could be cut, just cut it and solve the problem separately. What am I doing, bro? What am I doing? So, I mean it was visible in the hints. Root the tree. If a leaf is divisible by k, cut it, otherwise merge it to parent, meaning values of parent, add value of that node to its parent, and number is 1 plus number of cuts. So we basically just run the DFS, we start calculating the sum of values in subtree W. So we recursively do for child, and if child has size divisible by k, we just increase answer and then we add that. So okay, well, no matter if we cut it or not, we add this, because if we cut it and we add it, nothing changes. This still gonna be divisible by k even if we add this. So, and if it's not divisible by k, it doesn't change anything. So that's what I said here, and then we don't do any work at all almost, and store just this and adjacency matrix and the tree itself in an adjacency matrix in O of n, since there are O of n plus m, which is just O of n in our case, since there are O of n edges in A3. Okay, well, yeah, whatever. It's pretty easy. Good night.